Hello all, welcome to Shakti's AI Junction. In this video, I'm going to talk about two basic and most important topics in NLP and LLM space, and those are embeddings and cosine similarity. I have already spoken about embeddings in my previous video, but in this video we will see how embeddings and cosine similarity are useful in getting that relevant text or document, or relevant text or word. Let's get started. So what is embeddings? So I have already mentioned earlier, embeddings is a representation of your input words or sentence as a numerical vectors in higher dimension space. This vectors, which is called as embeddings, it captures the relationship and semantic meaning between your words or sentences. This will allow model to capture and analyze your human language. The basic concept is, similar words will have similar vector representation, and dissimilar words will have, different vector representations. This is the basic idea. And the example what I have, shown here, the cat is sitting on the mat. And if I convert as a embedding for each word, it's like, it will range from -1 to +1. And it is a 4-dimensional vector. That's the reason you are seeing a list of 4 elements. But in reality, the length of the list, or the number of elements could be more than 1000. In case of OpenAI, the embeddings is more than 1000. It's called as a I think it's 1048. So that's a 1040 dimensional vector. But here, for our simplicity, it is a 4-dimensional vector. Okay, so embeddings, we have converted our input text into a set of numerical vectors. Cosine similarity. So cosine similarity is a measure of a similarity between the two vectors based upon the cosine of the angle between them. Okay, the similarity value ranges from -1 to +1. If it is 1, which means the two vectors are very similar, and if it is -1, it is very dissimilar, and 0 also there is no similarity, which means there is no similarity. I mean, no such you cannot conclude whether this is similar or dissimilar. Okay, so embeddings, it will convert your text into a vector, and a cosine similarity, it will give a score whether the two vectors are similar or not. Okay, this is the interpretation. And let's take an example. So there are 2 vectors in the example. Okay, so what is that formula? So you have a 2 vectors, x and y, and a cosine similarity is a dot product of 2 vectors divided by magnitude of x vector into magnitude of y vector. Okay, so dot product is nothing but element wise multiplication. It's a pairwise addition. So it's 0.5 into 0.3 plus 0.8 into 0.6 plus 0.2 into 0.9 plus 0.4 into 0.1. So this is the dot product, and the magnitude is nothing but square root of sum of the squares of each individual elements. So for example, square root of sum of squares of each individual elements. So sum of squares in the sense 0.5 the whole square plus 0.8 the whole square plus 0.2 the whole square plus 0.5 the whole square, and you have to take a square root for that. So this is magnitude of A. Similar way, we have to calculate magnitude of B, and the cosine similarity is dot product of A and B divided by magnitude of A into magnitude of B. So here in this example, the cosine similarity is 0.724, which means this is closer to 1. So we can say the two vectors A and B are similar to each other. Okay, now we will see one example in my Google Colab by using Python program, and see how that embeddings and cosine similarity are interrelated. Let's see. Okay, so we don't need to go deeper into this. So we will see how embeddings are interpreted and how cosine similarity is useful to get the similar results. Okay, so for this I have used a transformer model, and SK learns a cosine similarity to calculate the cosine distance. Okay, And the model what I have used is SGPT model. So this is an LLM model, and you can imagine it is like it has been trained upon different text, lot of text, like your Wikipedia and your different codes. So it has been learned upon everything. So I mean the total size of the model is almost 6 GB, and we can download it with this command. Okay, with this model, and we are going to generate embeddings for our input documents. Okay, let's see that. This also covers how to generate embeddings, but on a basic on a high level, let's see like how those are interpreted. Okay, for example, let's say you have five different sentences, and each sentence gives a different meaning or different content, and you have an input query, and our requirement is to figure out which statement is closer to our input query. Like the input query is professor speech, and we need to figure out which one is more closer or relevant out of these 5 sentences. Okay, if you look at the sentences, the third one, in his eloquent speech, the renowned professor expounded upon the complexities of quantum mechanics. As a human, we would be able to say, okay, the third one is relevant to our input query. But how does a machine will understand? Okay, that we will see it. For that, actually, we have to create embeddings for documents separately and embeddings for query separately. So how are we generating? That is based upon the model that we have downloaded. Okay, and we are calculating the shape of query embedding as well as document embeddings. Here it is 1/768 for query. Remember, in the first slide I have told that is a 4-dimensional vector, but here it is a 768. So for our input query, it is 1/768. 768 denotes the number of elements, and for the document embedding, since there are 5 different sentences, so it is 5/768. The 768 is coming from the model SGPT model we have downloaded. If you go for OpenAI, this will be more like 1000 plus. So it's a 1000-dimensional vector. In order to calculate the cosine similarity, we have to convert into a NumPy array. So that has been done here, and we have to pass it to the cosine similarity function. Okay. And if you run that score, you will get 5 different scores. I mean, for each sentence you will get a similarity score. And if you look at it, 0.044, 101, 0.464, 0.06, 0.098. And which one is the highest of all these 5? Third one, 0.464 is the highest among these 5 values. And which means this is among the 5, the third sentence is similar or closer to our input query, and our input query is, the third one is like the speech about the professor. So this is the way how the machine will understand which is the relevant one. Let's say we can give some input query related to the first one. It's like it's a marathon runner. Okay, finish line. Something I'm giving like it's like weather forecast. And the similarity score for the first sentence, it should be higher when compared with the other 4 sentences. See, the other 4 are going in minus, whereas the first one is like 0.27. So among the 5, the first one is closer to our input query. So this is how we interpret by using embeddings and cosine similarity. And where OpenAI shines is that how these embeddings are getting generated. For example, for this input query, if it is generating some embedding value, different models such as OpenAI or Hugging Face, those embeddings will be very different, and they outperform in the way like how that embedding values differ. So that is like where we have to choose our best embedding model. Here, just for our simplicity to understand how this embeddings and the cosine similarity are related, we have taken a SGPT model. but when you go for some real world use cases, we always choose the best embeddings like OpenAI and Hugging Face Instructor. Yeah, we do choose the best embeddings. We will see we will see more in our upcoming videos, like with using OpenAI, like how to generate embeddings for one entire PDF document, and how do we compare against our input query. So we will see that in upcoming videos. Thank you all, and like, subscribe to Shakti's AI Junction.